Alrighty, so this was the lab test that we did last week. So we had to make this little sketch, and there was just two versions of it. There was one for the early class and one for the afternoon class. And as you can see, the sketch is pretty much the same for both the early and the afternoon class. Just one just moved slightly. One moved from left to right, the other one moved from top to bottom. So I'm going to do one version of it. I'll do this version, which is the sideways version, rather than the up and down version. But the up and down version is kind of the same. So let's start off a blank processing sketch, and we'll do this kind of step by step, right? Let's come back to here to see what was the question. So first of all, we have to draw the road. So let's do the simple thing first of all. Let's just set the size of the screen. Okay, now to draw the road, there's two parts to drawing the road. There's to draw the grey rectangle for the road, and then there's to draw the road markings, the lines, okay? So we'll do those in two separate parts. First of all, let's draw the rectangle. So, what did I declare here? I declared a variable called road width, just because I think I like to be able to maybe change this variable. What's that?
The bracket.
Oh yeah, good man.
It was so game. You're very aggressive. I'm very nice.
So I set my road width equals to 100. This is going to be the width of my road, okay? So let's draw the grey line first of all. Well, let's put in background first of all. So I've got background 0. And now it's time to draw the rectangle. Okay, so what do you think the x-coordinate of the rectangle is going to be, given that it has to go from the extreme left of the screen to the extreme right-hand side of the screen? So what's our first x-coordinate? 0. X-coordinate will be 0, yeah, awesome, because we're at the extreme left-hand side of the screen. Now, what's my first y-coordinate? Given that I want my road to be drawn in the center of the screen, and I want it to be centered around that road width thing. Height divided by 4?
0.5. Ah, in the middle.
Yeah, how about something like height divided by 2, which will give you the center of the screen, and then minus road width divided by 2.
Oh, then you're the center line.
Because I want to, I want the center, sorry, what do I want here? I want the top left-hand corner of it, right? If we draw it out like this, you'll see that if I want it to be centered in the screen like that, then there's my road width there. And the coordinate I'm trying to calculate is this coordinate here. Here's the center of the screen. So you can see this is obviously going to be height divided by 2 here. But then I also have to subtract this bit here, because I'm trying to calculate the top left-hand corner of the road. So I'm going to take road width divided by 2 and subtract that from height divided by 2, and then that's going to give me the coordinate there in the top left-hand corner. Does everybody get that? Alright, so let's do that. Actually, what I'm probably going to do here is I'm going to declare another variable called y, because it'll be handy to have this variable. Say that's equals to height multiplied by 0.5f. Okay? So then we're going to take 0 and down y minus road width multiplied by 0.5f. Okay, so I'm going to just move up a little bit. And what's my x2 going to be? The extreme right of the screen? Yeah, it'll be 500. But can I use a variable?
Yeah, width.
Yeah, let's use width, okay? And then let's put road width, y plus road width multiplied by 0.5f. Oh, hang on a sec. Yeah, width is correct. This should be just, because it's rect, the last parameter for rect is just road width. Yeah, not forgetting that the parameters for rect are x1, y1, the width and the height of the rectangle that you want to draw. So if I'm going to move up half the thing, then I want to draw down the full road width here. So that's going to that's going to do the road width and down. And again, you could have come up with a different solution to this. This is just the way I did it. And then let's actually make our road grey. So I'm just going to use 50% of the colour intensity for the grey, and then that gives me a grey road. Now the nice thing about this grey road is I now have equal space above the road and equal space below the road, and it's nicely centred in the screen. Again, this is the centre of the screen, so to get the coordinate of the top left-hand corner, I go up half the width of the road again, and that gives me that coordinate in the top left-hand corner there. Is that okay with everybody? Okay, so that's the road. Now, obviously that's pretty easy. The next, and I suppose slightly more interesting and challenging part, is to do the lines going across the road. Now I was just looking around and it seemed again that most people figured out how to do this. This is a for loop. Okay, so if we analyse what this looks like, imagine that this is my thing which is going from left to right across the screen. You can see I do one there, then I have a little gap, then I have another one. So I have all of these lines here, and all you need to do is figure out what's the interval you want to have between each of those lines. And you just pick a number. Say I want to have 100 between here and here. I think 100 is probably too big, but we'll make a variable out of it as well. We ask some question?
Yeah, when I try to run the code as it is, a problem arises at the second flow equals second token.
This code here?
Yes.
Which float?
Second.
Maybe just check to make sure you get a semicolon on the previous line. I'm not too sure. If you show it to me, I'm sure we'll figure it out, right? That code should work. I don't think there's anything too wild about it. But yeah, so anyway, I just need to calculate this x-coordinate here, which as you might imagine is just increasing, it's an equal distance between all of those things. So I just calculate this x-coordinate and I draw a small line across like that. Is that okay with everybody? So, let's do that. So we're going to start at 0. Let's do stroke 255 first of all to make a white background. Okay, and then we just decide whatever our, sorry, you don't want to do x plus plus. Let's do x plus equals to, what did I use in my solution? I used 50, okay, so this puts a gap of 50 in between each of those x coordinates, and then I just draw my line from the x coordinate, y, which is the center of the screen, and then the second two coordinates are the x2, y2, so let's take x plus, what did I do in my solution here? I think I did x plus 20, which leaves a gap of 30, and then down y. So that's going to draw my lines in the center of the screen. So what you can see is happening here is the x-coordinate for the start of each line is increasing by 50, and then I just draw short lines so that they don't all join up, and then I add 20 to the x-coordinate to get the end coordinate of the line. So let's run that and see what happens. Alright, so now I have these lines going across the screen. And as you can see, this is starting at 0, this is starting at 50, 100, 150, 200, 250, and so on across the screen. And then I just draw them slightly shorter than the interval, and then that's what causes the gap to appear. Is that okay with everybody? Just hopefully everyone got that. I presume everyone got that. Just looking around the screen, it seemed that most people had figured out how to do that for loop as well. So the next thing we're going to do is draw the car. Okay? So what I did for this is I declared another variable of type color, and I called it C. I could have called it car color, but it doesn't really matter. And up here in setup, I give my variable C some starting value, so that when the car gets drawn for the first time, I know what color it's going to be. So C equals color, and we can make a random color. So, remembering this is how we do a random color. Right, so that gives it initial color. So that's up there in setup. So that means when my program runs, it has a color.
You can say just color C equals random.
Just one word?
No, as in, yeah, so color.
Yep.
The
Oh,
keyword
really?
color,
Okay.
Yeah, and then color change equals color random.
Say again.
So what I did is I named a colour
Yep.
called colour change.
Sure.
And I equal that just to a random 0, 2, 5, 0, 2, 5, 5, 0.
Same as this, or?
Almost, except I stated, like I used similar, I didn't sorry.
Oh. You just did it all in one go?
I did it all in one
Oh,
go,
okay.
yeah.
Yeah, I don't know why. Well, I'll tell you what, when I come up with a solution, maybe you'll see why I made it a global. Because I'm only changing it intermittently. I wanted to remember from one frame to the next what the colour is. I only change the colour whenever I change direction. So we'll just draw a car for now. So I need a couple of variables for the car. So let's make one other variable called x for the car. And maybe I'll start that at 0, okay? So my x value is basically where the car is going to start. Oh, in fact, let's make a couple of other variables here, right? We might as well. Car length. I said that my car length is equals to 80. And my car width, I said, was equals to 30. It makes it a little bit easier if you just declare some variables rather than hard code those numbers later in my program. Now, actually, there is something slightly weird, slightly interesting here. Right? If you notice in the video, there's my screen, and there's the road like that. The car doesn't actually, the car goes along the left-hand side of the screen like that. But if I want my car to start off the screen, what should I set the initial x coordinate to be? Assuming I'm going to draw this using a rect. I should be a minus value. In other words, it should be off the screen here. I'm really glad that people noticed that. So if I start my x coordinate there, then that means that, you know, this is going to be minus the car length for the x coordinate. That means it's going to be right off the screen when it starts. That's a good way to get it to go right off the screen when it starts. So let's do that. My x is going to be equals to minus the car length. And let's just draw the car, and then we'll get it moving first of all, and then we'll iterate this. Alright, so let's draw the car. First of all, stroke C and fill C. So that sets the stroke and fill color to be that variable C that I created earlier on in my sketch. And then let's draw the rectangle for the car. So the x coordinate is going to be car x. Or did I call it car x, or did I just call it x? Let's call it car x. So my y here, we need to think about this just very slightly because it's not that hard to figure out, but nevertheless, you could just hard code it until it works, but we'll see if we can actually work it out using a variable. So I have the center here. What do I want it to be? I want it to be, my y is going to be here. So what am I to do to make that? Like if that's the center of that line there, that's the way I want it to be. So I need to basically take this value here, which is going to be y minus road width divided by 2 to get this center line. And then I need to also subtract the y for the car as well, the car's width, to get this top corner here. Does everybody kind of see what I'm doing there? You know, if you just draw it out, you'll see how you can calculate this y coordinate here by just taking the center and then the width, and then there's a little bit of work involved. Okay, so let's set the car y. Oh, hang on a sec. Y minus road width divided by 4. Yeah, you can, totally. Yeah, if you find that easier, definitely. It saves you calculating different things. Yeah, you can change the rectangle mode. Okay, here's the way I calculated it, right? Float y, let's call this car y, is going to be equal to the y, which is the center, minus the road width divided by 4. Or let's do this, multiply by 0.25. Now, I'm just noticing, this is what I had in my solution, so let's see if this makes sense. So the road width is the total width, and then I'm subtracting a quarter of the total road width to get the car y. Does that make sense? So, okay, maybe it does make sense. There's my road again. There's loads of ways you can calculate this, you know. This is one of many ways. I basically said, that's my road, that's going to be the top. Okay, so I just basically subtract a quarter of the road width, and that's how I calculated the y coordinate. There's loads of ways you could have done that, right? I just literally took this, divided it into 4, and then subtracted that from the y. and then that worked. But like I say, there's loads of ways. You could do it the really kind of proper way, which is to calculate this center line here, and then subtract half the height of the car. That's probably a better way to do it. Nevertheless, this seems to work okay. So then let's go car Y. And then the next two parameters are going to be car length and car width. Okay, and that's just to make something happen here, because otherwise we won't see it, it'll be drawn off the screen. Let's go car x plus plus, so that we can actually see it on the screen, hopefully. Alright, there it is. That didn't quite work out as well as I thought it would. How come it worked? I did car y equals y minus.
Subtract the half of the width of the car.
What again there?
Yeah, that seemed to work in my solution, but it doesn't seem to work now for some reason.
What again?
You need to subtract the car width also.
Yeah, I'll tell you what, I think my solution, I'm not quite sure why it worked in my solution, but this doesn't look entirely wrong. Let's do it a slightly more complete way. We'll actually calculate it. So the center line here is going to be, that's a quarter. Oh yeah, so you have to subtract the width of the car as well, the height of the car, half the height of the car. Car y equals, oh, so I see what I did. Yeah, okay. I see what I did with it. Yeah. So you're right, it should be actually all of this amount here, and then we put brackets here, and then you have to also subtract the car width multiplied by 0.5 f. Yeah, I see where my solution is slightly off. There we go. Alright, so what I've done in order to calculate that, sorry for the confusion there. What I did is first of all calculate this, so that this is equal to the y and it's a quarter of the road. In other words, like halfway between the top and the bottom, the top and the center line. And then I also subtract half the car width as well, and then that gives me the exact coordinate of the top left hand corner of the car. Okay, so now my car is moving.
So what was that minus car width that you just added on there?
I'll show you what I had. Yeah. So I took y minus the road width multiplied by 0.25, which is a quarter of it, to get halfway up there, and then I also subtract the car width multiplied by half, so that brings me half the car width up again, you know. So that's how I did that, and then I have, oh yeah, so I want my car to move now. So if you guys remember, probably the most straightforward way to do this is to make one other variable called car deer, which tells you which direction the car is driving. So we want our car initially to go in the direction from left to right. So if I said car deer equals to 1, instead of doing car plus plus, you do car plus equals to car deer. So that's going to be the same thing, because car deer is 1. So it's going to basically just add 1 to the car position each time around, each frame. So car x plus equals to car deer. Okay, so that's just using a variable to control the direction. And just to make sure that that's going to work, let's just run first to make sure that we haven't messed anything up here. Alright, so there's my car moving in the right direction now with the car deer variable. Now what we need to say is if the car goes all the way to the right hand side of the screen, that I switch the direction and bring the car back again. Yeah.
Where is the car deer variable?
I just declared it as a global variable and I gave it a value of 1. So that just means initially the car is going to be adding 1 to its x coordinate each frame. Yeah.
I don't think you couldn't declare the variables were hidden down.
No, you can, but there'll be only
Declare variables here. Oh, of course you can, yeah. It's very, you need to. These are called local variables. The thing about a local variable is a local variable can only be used inside this method. In other words, every time this method gets created, the variable y gets recreated with this value. So it won't hold its value from one frame to the next. But of course, you need to declare variables here. In fact, the preference should always be to declare variables here, rather than declare them globally. Okay, so you want to always declare your variables inside the method if you can help it at all. It's better because it makes your variables more modular, your methods more modular. Yeah.
It's not better to set the globals to private and then set the functions.
I mean private as in Java private?
Yeah.
So in processing we do away with private and
Okay.
public and everything is public, yeah?
Okay.
Yeah. So they're global variables. There's card here. I've set it equals to be 1, okay? Of course you can do all your calculations in the draw stuff. So there's my card here, and now I'm adding 1 to it. And now what I need to do is check to see if my car goes beyond the right-hand side of the screen. So what I'm looking for now is to see if the left-hand side of the car reaches the right-hand side of the screen. Then I know I've completely gone off the screen. So I check to see if my car X is greater than the width of the screen. Then a few things need to happen. Well, simple thing, car dear equals -1. Alright, this is going to get it to come back again. And then also we want to change the color. So C equals, and I'm going to copy and paste my code up here. Because every time the car changes direction, I wanted to change color as well. Alright, so let's see what's going to happen here. Hopefully you should get to the end. The card here should change. It won't come back on the far side here because I need to also change the Y value.
Would you not use a Boolean?
Huh?
A Boolean for the car direction?
Could do. But I already have one. I have card here.
Okay.
So you could definitely make another Boolean variable, and that's no problem at all. Okay, so now of course there's 2 extra things. Once it gets to the extreme left, I need to send it back again. And so that's going to be another if statement. And then also I needed to switch sides of the screen as well, depending on whether it's going to the left or to the right. So now I check to see if my car X, okay, the extreme left-hand side of the screen. The extreme left-hand side of the screen is slightly trickier because what I need to do is make sure that the right-hand side of the car, if you look at how the car looks, yeah, it's going to be width minus the car length, yeah? So here's my car. I need to make sure that my car has gone entirely off the screen. If my car has gone entirely off the screen, it's the right-hand side of the car that I need to check. So this is going to be the car X plus the car width, plus the car length, isn't it?
Yeah.
That's the right-hand side of the screen. So I need to check if that is less than 0. Then I switch my direction the other way and change the color the other way. So if car X plus the car length is less than 0, then I need to switch my car direction and change the color as well. Okay, I think this is going to work okay, but there might be one extra thing that we might want to add, but I think it's going to be okay. So now it's going to go from left to right, and then once it goes from left to right, that if statement should become true, and then it should move from right to left, because I've now changed card here. Alright, so at this point card here was 1, now card here is -1, so I'm adding -1 to it. And then hopefully when it gets all the way to there, yeah, there we go. Card here becomes 1 again, and I change the color, and now it's moving from right to left. That okay with everybody? So now, the last thing we need to do is just get it to switch sides depending on which direction it's going. So this is kind of, again, you could use Booleans, all kinds of stuff to solve that, but I think a nice way is just to change how car X is being calculated. Alright? Sorry, car Y. So then we say, if the card here is equals to 1. In other words, if I'm moving from left to right, I'm going to set my car Y to be equals to this value here.
Better just to put the car, change the Y in both the ifs that you have.
Yeah, that is definitely a better way, yeah. So, but what I need to do is I would need to move this code up above where I'm doing the drawing. Yeah, that would work as well. Let's try that.
Where is this going?
So, no, we're going to try, what's your name again? Aaron, right, we're going to make a different suggestion here. Aaron is suggesting, why do I have to bother with this extra if statement? And it's a good point. I would need to move this code down to here, because I need to calculate the x and y. So then if car, yeah, you would definitely need to set car y. How many people did it using two if statements, or two sets of if statements? How many people did it all in the one set of if statements? Yeah. You didn't bother having a separate set of if statements to calculate the y, you just did it here? Okay, I'll do it here. Yeah. So now if I'm moving backwards, car y is going to be equals to, I shouldn't have deleted all that code because now I have to write it again.
Car width multiplied by 10.
Say again?
The car y is equal to car width multiplied by 10.
But it's not going to be car width. It's the center of the screen minus.
Because you're multiplied by half and up from the center of the screen.
Yeah, it's still a slightly more complicated. I still need to calculate it. Car y is equals to
Car y less half the road.
car
Y
minus road width multiplied by 0.25 minus car width multiplied by 0.5 f. There we go. Otherwise, I change my car width to be this. So that'll be y plus this. Yeah, if I'm going in the opposite direction. And then you do need to set it to be, probably need to take this and make it not a global variable. And then we need to give it an initial value, yeah? Did you have to give it an initial value?
Yeah, that was
Sure thing, yeah. So you just did it gave it some initial value here, huh?
Yeah. I think that was the base. The size of the screen channel.
Brian,
Yes.
the car y is easier if you calculate it like the same car y less the half the road. Car y equals to car y less road width.
Yeah, then it'll be the extreme left of the, it'll be actually lined up with the road, whereas I want it to be halfway along the road.
There is a difference between lanes. There's a difference of half the road. If you move the car like
Sure, so I just need to add to it, yeah.
add half the road to the
Add
car
half
y.
the road to it, exactly, yeah. Definitely, that will work as well, right?
And
Let me just see if this works, because I think it's almost there.
one of the ifs is with plus, and the other one is with minus.
Exactly, yeah. Oh yeah, car y. See, the way I did this, I made the y a local variable, so now I'm going to I'll make the y a global variable. Okay, so let's make the y a global variable then. Okay, let's just see, does it work? And then I'll just go back through it again. So hopefully each should have its initial value. At this point, nope, it didn't work. Why does it not work?
You have to put the car y is equals car y less half the road.
Let's think about this one here. Is this more or less what you had? Multiply by 0.25 is the same as divide by 4. So I take y plus the road width multiplied by 0.25. So y is the center. Oh!
You had an extra bracket around y and round width multiplied by 25.
Yeah, okay, maybe that's the reason why. But hang on, I think we should just calculate it from the bottom there again. It's a slightly different calculation. I want it to be here. So this is going to be the center, and then I need to subtract that. So why is that not working? That looks like it should
The
work.
difference between the previous state and the new state is just half the row. So if car y is equal to car y plus half the row.
Okay, that would work as well.
Or
Yeah.
less, you know.
That's why you have it.
Yeah, so that will work as well. So all I do is take the old y value and I add half the row width to it. So
And
lose
less,
it from the top to the bottom.
and
Yeah.
less in the other. In the other if statement is less than half the row. So it will change lane all the time. No, in the one
I
of
should
the
have just
top-
stuck to my own solution. Now I'm confused.
No, but if you put that, that's exactly that. In the other if statement,
Oh, this if statement here.
yeah, in one of them, you-
Guys, just be quiet for a second, will you? So we can have a
the position of the
conversation.
car is here. When it reaches here, it will change the lane. This is half the road width, you know, and when it reaches the road,
I don't know what you mean.
so it's basically it's copy that thing, put
This
it.
thing?
Yeah, put it there. Car y plus road
okay.
width.
That's
Oh, I've done it the wrong way around, have
yeah,
I?
you've done car
Oh, okay.
minus or less than
So this is on the left-hand side. So once it reaches the left-hand side, it should go to the...
Less, there is less road width. And in the top, so you have to say that is
Should be the opposite way around. So once I get greater than that, my car y should be this way.
Yeah, that's gonna work.
Huh?
That's gonna work.
Okay.
And the other, and then in the other statement, you have to substitute. In the other if, you can calculate that with just instead of all that, like
Yeah.
less the road width.
This one here.
Yeah, exactly the same code as previously, but with a less.
Oh, sure. Yeah, because we've already calculated the initial value. Yes, I understand completely. Yeah, okay, cool. That would make sense as well. Yeah, that's better. Cleaner than my solution. So this, then, we just take car y. Because it assumes you're only doing the switch. You're only doing this calculation when you're switching. So you've already calculated the initial value for y. So then, like that, should do the same thing, yeah? So every time I switch, then I recalculate a value for y. Alright, my solution that I put up on the website is slightly different. It's a more complicated solution than this because I've got an extra set of if statements for changing the y coordinates. But I guess, yeah, this makes more sense to do just one set of if statements for changing the y coordinates. Alright, so just to be clear to everybody, this is kind of where I need you to be at this stage of the course, right? You need to be able to look at something on the screen, figure out what way the coordinates need to go, figure out what you need to calculate, obviously do all the drawing code, know where to put your code, know how to do the if statement, and know how to do all the drawing stuff, okay? And then know how to do loops. So that's where we need to be at this stage of the course, right? So the next thing that we're going to talk about on this course is how to make our sketches more what's called modular, right? We're looking at this sketch here, and all of the sketches that we've written so far, we've just put everything into the setup and the draw methods, right? So now what we're going to start doing is we're going to start writing our own methods, and that will make our sketches a lot more, the code in our sketches a lot more reusable, and hopefully our code is going to end up looking cleaner. Alright, so how do methods work? Well, it turns out that you guys already know how to do methods, because we've been doing them all the semester. Ever since we started, we've been making one or other types of methods. The type of methods that we make really get divided into two different categories, right? Category, what's that? Oh yeah, so category number one is the type of methods that we've been putting in our sketches. So when we put stuff like void setup and void draw, these are one types of methods, alright? These are one type of methods. What other methods have we been using in our sketches? Okay, so we got setup and draw. Have we used methods already?
I used the method in my program.
What one did you use? Okay, there's another one, size. Actually, that kind of falls into a little bit of both, but really this is in the same category as these types of methods here.
Background, rect.
Yeah, all of these stuff like background.
Oh, built in.
Sure. And so on. All of these, what other ones have we used? There's a different category of methods that we have also used. What's the significance of all of these ones compared to the other types of methods? What other methods have we used? Yep, sure thing. They all fit into this category of methods here, in that they are methods which do a job for us. There's another type of method that we've used. What's that?
Ones that return a value?
Yes, ones that return a value. Give me some examples of methods that return a value.
Random print.
Interestingly, print doesn't return a value. Yeah?
Yeah,
Print just
random.
does something for us. It also fits into this category here.
Yeah, cosine?
Yeah, exactly. So we have some methods like sine, which take some number and give us something back out the other side, right? And we have another method here called cos, which does the same thing, does some calculation and returns something back to us.
Oh, like degrees and radians.
Yes, degrees is another one. Degrees, radians, huh?
Pi.
Yeah, they're what are called constants, so they're not methods, right? One other one that we might have used is pow. Have we used pow? Okay, pow means get one number to the power of another. Another number we might have used, or another one we might have used is sqrt square root.
Yeah. Random.
Random, another great one, yeah.
Modulus.
Modulus is what we call an operator as opposed to a method, right? A method, let's see if we can from this here figure out what are the characteristics that a method has, right? Looking at these examples here, if I said to you there's two different types of methods, can you tell looking at this list here what's the difference between these types of methods and these methods? Well, tell me, what is the difference?
Void and return.
What's that?
Void and return.
Okay, so these are methods here where we just call the method and we don't get anything back from the method. With all of these ones here, sine, cosine, degrees, radians, pow, square root, and random, we call the method and we get some number back out of the method. Does everybody understand that? Yeah. When you call something like sqrt and you pass in 9 in it, what comes out? 3. Okay, so you get a number out of it, right? So these are the characteristics of the methods, right? Some methods return some stuff, some methods just go and perform a task. Next thing that we can say about methods, is there any difference between something like setup and draw and size and background and rect?
Number of parameters.
Yeah, so some methods we have to give it some numbers and some methods we don't give it some numbers. Alright, so there's the characteristics of methods. I'm just going to put a note up here, okay? So some return values, and this is optional. Some take values, and again these are optional. And these values that the method takes, they're called parameters. Another word for parameters, you might see it in some programming books. Arguments, okay? Okay, next of all, if we're making methods of our own, what should we name our methods? Should they be verbs or nouns?
Verb.
Yes, verbs. They should be always verbs, because a method is something that's going to do some calculation. Alright, so these are rect. In other words, draw a rectangle, or background. Draw the background. Usually it's something like do this, or calculate that, or whatever, okay? So they should be typically verbs. And the general structure then for making a method looks like this. Say I want to make a method. First thing, say test. So we've written setup and draw because they're built into processing. Like, you should be taking notes when I'm writing stuff up on the whiteboard, either on your computers or on pen and paper, right? So when we're making a method, we say a few things about it. First of all, this is going to be what we call the method name, right? This is just the name of the method. This keyword here, void, which we have at the beginning of the methods that we've already made in processing, this specifies what do you think this specifies about a method? It doesn't need a return type. Okay, so this word that comes before the name of the method is called a return type. The return type for all of those methods that we were using earlier on the left-hand side of the table, they all have no return. And in other words, their return type is void. Void means that this method doesn't return anything back again. So then you put your parameter list over here when you're making a method. In your parameter list, you specify the type of each variable, the name of each variable, and you separate them all with a comma. So if I wanted to have this method test, which is just going to print somebody's name, I can go string to say that it's a sequence of characters, and then you give your variable a name like that. So you go string n, and then you can go print, open bracket n like that, and that's a very simple example of a method that just takes one parameter, doesn't return anything back, just does something with the parameter. At some later stage in your program, you're going to want to call this method. So to call a method is very simple. You just go test, and then you put the parameter list like this. So when you go test, open brackets, you pass in Brian inside two quotes like this. What will happen is control of your program will jump to this line of the program. It will execute this line of the program, and then control will return to the line after you've executed, after you've called your method. So this is with methods that don't return a value. Methods that return a value, they look pretty much the same thing, apart from you have 2 or 3 extra little bits here. The first thing that happens is you specify what type of information should this method return. So for example, I wanted to write a method called add that's just going to add 2 numbers up together. I can say that it returns a float, and then it's going to take 2 parameters. So we can go float A, comma, float B, like that, and then you go somewhere in your method you have to have the keyword return, like that. So what it does is it adds up A and B together and then sends the output of that back to the program, or back to the thing that called it.
Just to take note, does the float need to be a capital F
No, float only needs to be a capital F if we're using it in an array list. In other words, we're passing that as a type, and that's what's called an object wrapper. So, but in this example, no, float is okay as a lowercase f, right? So, return, what that does is it takes the output of A and B and sends it back to the caller. So in this example, if I just did, I'll show you. If I just wrote add add 10, 20, like that, and I didn't do anything with the return type. In this example, it won't do anything. But what you can do is something like C equals A, add 10, 20, and then C will take the value of whatever gets returned. So in the same way that previously we were doing like sine of theta, you know, or like something equals the sine of theta, you have to go something equals the return value of the method like this. And that's how return values of methods work. Right, let's type a couple of these examples up in processing, and I'll give you guys a load of methods to write, simple methods just to do some things, to get some practice at all of this. This is the theory, there's nothing more to methods than this. Just a new keyword, return, how you specify your methods, and it's really good now because what we can do is, I can say, write a method to do this instead of write a processing sketch to do this. And then also it means that our processing sketches, hopefully the draw and the setup become quite small, and we end up writing methods to do the other parts of our program. It's good because we end up making what's called a modular program. In other words, our program is divided up into sections which perform different tasks in the program for us.
I don't know what to describe it in an area of place.
Yes, sure, have a look at that. Yeah. Sure. stuff, yeah. I'll tell you what, we'll come back to you here in a little while if that's okay, right? Cool. Okay, let's just write some methods here, alright? So let's put a simple process and sketch together, void setup. And let's not even put a draw for now. Okay? So those couple of examples that I wrote, let's do the simplest possible examples of methods. And really, like I said, there's not a lot more to it than this. Let's just do void test method. In fact, let's not call it test method. Let's call it say hello. And its job is going to be to say hello. Alright, so that's what my method looks like. Say hello, pass in a string, and it will do some operation, and there's no return value. So then here I can call say hello, pass in a value here. Alright. Okay, so just to be clear what happens here, the first time you call say hello, the value of Brian gets passed in as the parameter name here. So name takes the value of the string Brian, and then you call println hello followed by name, which will be the value Brian. And then the second time around, the value of Misty gets passed in for name. So the value, the name variable this time is going to hold the value Misty. So when I go println hello, it will print Misty. Is that okay with everybody? That's how methods work, and that's how parameter passing works. So some other types of methods are those methods that return some values. So say I write something very simple called float add. And all this method is going to do is add two numbers. Let me call it add floats or add numbers, because it looks like add might be already something in processing. So I go float A, float B, and then we have this value return. So of course that doesn't change the value of A or B. All it does is it adds those two numbers together and then returns it back to the caller. So you can call add numbers 10, 20. In this example here, it's going to ignore the return value. Alright, because this return value of A plus B just gets thrown away in this example. But you can also go float C equals add numbers. And in this example here, what's going to happen is A takes the value of 20, B takes the value of 30, and then C is going to have the value A plus B, which is 50. Alright, so that's methods. There's really nothing more. Well, there's a couple of other like gotchas, but I think it's probably a good idea for you guys to write some methods just for some practice. Is that okay with everybody?
You couldn't scroll down.
Sure thing, yeah. Is that okay?
Just tried to run the code as is. It said that there is no expected token.
I'm sorry, I can't hear you.
It said that float right there is not expected token when I tried to run the code as is.
Yeah, I'll have a look at your program. I mean, you're probably missing a semicolon or a comma or something, but I'll have a look at it if you want to show it to me, okay?
Should that be doing something?
So all it's going to do is print some stuff out, and you see, because I haven't actually printed the value of C, it doesn't print C, so print ln C. You can also do something like this. You can take the return value and just pass it into another method. So you can go print ln like that, you know, so you can just take the return value and pass it as an input to another thing. Alright, that's how methods work in processing. Okay, I'm going to put up a couple of examples for you guys to do, and then maybe we'll just take like a 5-minute break or something. You can start working on these right now, okay? And you might need to look up these, okay? So let's write a couple of methods here. Let's write the following methods. Okay, write a method called circle that draws a circle. Think about what parameters it needs. Does it return a value or not? Write a method called that's probably spelled incorrectly. How do you spell Fahrenheit?
You don't know.
Is it correct? That's wrong. Okay, write a method called Celsius to Fahrenheit that takes in a value in Celsius and then returns the value back in Fahrenheit. Okay? You need to look it up. I can't remember. You multiply the number by something and divide by something else. Okay, it's just something that you can Google how to do that conversion.
What's the circle part for? What do you want to do with the circle?
You think about it. I want you to write a method that you're going to pass in. What parameters would you need to draw a circle? No, so we're going to use an ellipse, but assuming that there's no method in processing for drawing a circle, this method is going to draw a circle for us. Now hang on, I don't want you to calculate it using sine and cosine. I want you to call...
So if you make the method and call it.
No, you're going to make a method called circle, right? What parameters would that method take if you were writing a circle method? What would it need? Yeah, we already have one called width and height, which draws an ellipse. I want to draw a circle.
Center point, the radius.
Center point and the radius, okay? And then you can call ellipse to draw the actual circle based on those parameters that are passed in. You follow? Alright, so there's a couple just to get started. And there's a third one there, distance. What I want distance to do is calculate the distance between 2 points on the screen. So I'm going to pass in x1, y1, x2, y2, and you tell me what's the distance between those 2 points. Alright, have a crack at writing those 3 methods to get started, just for some practice, okay? And then we'll come together and we'll write them. Okay, everybody, now that everyone's had their sugar and caffeine, let's try the first one, the circle one. So, what we're getting at here is being able to analyze these and figure out, does it have a return type? What are the parameters? And what does the method need to do? So first of all, this circle one, this is not going to return anything. This is just going to do something for us. It's in the same category as stuff like setup and draw and background and line and ellipse. It doesn't return anything. It just does a job and has no return type. So therefore its return type is going to be void. Void means it doesn't return anything. It just does a job. Now if I was writing a processing sketch and I wanted to write a method that drew a circle, I would probably want it to take parameters. So what do you think the parameters should be? X, Y, yeah, and the radius. Cool. Alright, so it's going to take the x and y and the radius, and then I might use an ellipse to draw it. Got x and y. And then the last parameter for ellipse, the last 2 parameters are the width and the height. So we'll try and write this as in terms of radius. Alright, so because the last 2 parameters are width and height, I have to take the radius and multiply it by 2 to get the width and the height. And that's what my circle method might look like. So over here, I can now call circle. I can pass in 10, 10, and that's going to give me a circle of radius 20. And that's the first one. Alright, so there's my circle method created. Let's see, what was the next one? The next one was the Celsius to Fahrenheit. How many people have the Fahrenheit to Celsius one done? Okay, well I'll let people work on that for another couple of minutes, and if you're still working, you know, that's fine as well, okay? Celsius to Fahrenheit, and then the distance method then, okay? Okay, bit quiet for a second, please. Quiet, everybody, please. Okay. Celsius to Fahrenheit is in that second category of methods, in that it's a method which means to return a value. So you go float. So, and I've double checked the spelling now, so apologies for my bad spelling earlier. That's the way you spell Celsius and Fahrenheit. So Celsius to Fahrenheit. So what we're doing is we're passing in one number in Celsius. And we're going to return the same number in Fahrenheit. And we discovered that, what was it? We multiply by 1.8 and then add 32. And then we add 32. So let's test to make sure that works now. So we pass in 100 degrees Celsius and we find out what that is in Fahrenheit. Thank you. So 100 degrees Fahrenheit is 212 degrees in Celsius. Let's just check that. I want to do Celsius to Fahrenheit, so 100, 212. That seems to be okay. So what did you I'll show you. I returned the, here we go. So I take Celsius multiplied by 1.8 and then I add 32 to it. So like this, just be clear, if you understand these two examples, you'll understand methods, you know. So the two examples here, this one is the previous one where it was the circle one, is an example of like an action or a verb that we've made into a method. In other words, it just does something and it doesn't do any calculation as such that we need to calculate or return. This is an example here where it's not going to print or draw anything, it's just going to do a calculation and tell us what the answer is. Is everybody clear on those distinctions between those two methods? Some of them are void if they don't tell us anything, and then some of them, they return some value back. And then these become like functions that you can call and you can get them to evaluate some numbers and send you some answers back. So I just did print ln, print to the console, and I just did Celsius to Fahrenheit. So that takes the return value of Celsius to Fahrenheit and then passes that as a parameter to the print ln method. Print ln takes a string. Yeah.
To put it into like plain English, is that receive float void? Is that basically that little block of it is basically just saying what I want from you?
Yep.
Okay, cool.
Yeah, it's the return type, either void or float or int or whatever. So the third one is similar to the first two in that it's just 1, 2, 3. The distance is just going to take 4 parameters and going to return one float. There's already one built into processing called dist, but nevertheless. Alright, so we pass in 4 numbers, and what this method is going to do is calculate the distance between those 2 sets of coordinates and return that as a float. So you can do this in separate stages, but we'll just do it all in one go. And you might remember that the distance between 2 lines is the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So SQRT is built into processing. We'll give you the square root of a number. And then what we need to do is calculate the square root of, so many ways to do this. We can use POW, x2 minus x1 comma 2 plus POW y2 minus y1 comma 2. Of course, we should probably do that as 2.0f just to make sure that everything happens in float. Just get into the habit of doing that. Alright, so you might remember that formula from your school days. It's the square root of x2 minus x1, sorry, x2 minus x1 be squared plus y2 minus y1 to be squared like that.
Your second x2 should be x1.
Yeah, so that's in that category of methods as well that also take parameters and that return something. Now sometimes you might think, well, I'll print the value out here, but this shouldn't really print anything ever. The reason why is because this method is called dist. Okay, somebody reading this is going to assume that this method is calculating the distance. It doesn't say anything in the method signature to say that this method is going to print anything. So the method shouldn't have any side effects. It shouldn't do anything that isn't, you know, part of what the method is supposed to do. So it shouldn't be writing to a file or printing to the screen or drawing anything unless it's actually there as part of the method name. Yeah?
What does pow do?
Pow means power. So it takes this number to the power of this number.
Okay,
So
so
it's
that's
squared. Yeah. Another way to write that would just be x2 minus x1 multiplied by x2 minus x1. Yeah.
What happens if, for example, we want to calculate which is the one of the two pairs that is closest to a point? You have to return two values instead of one. Is that possible or not?
Say again. You want to write a different method?
I want to return instead of just one value.
Yeah.
Like a coordinate, for example, like 0, 0.
Oh, sure. It becomes quite tricky actually because what you have to do is return an instance of a class.
I have to create a.
You have to create a class to encapsulate those two values. That's the only way to return two numbers.
And instead of float, you put that class there.
Yeah, you return the class. Yeah, and then you return a new instance of the class. Okay, we're almost done. I want to show you one simple thing. What this is usually used for is this is usually used to do what's called modular programming. So. So I want to come back to BugZap for a minute and just show you something in BugZap. Where's BugZap going? Okay, why don't you just take a look at my code for a second here. This is how you write a long processing sketch, right? This is just to show you how you take the stuff we've learned on this course and how you apply it to a real world problem. So this is my version of BugZap. It's a much bigger and more complex version that has a splash screen and a loading screen and a game over screen. And also I've done this in this modular way by using methods. So you notice, for example, I have a method called play sound. Anytime I want to play a sound, I just call this method, pass in the sound, and it does some stuff to check to see can the sound play, and then it goes and plays it. Similarly, I have a method here called splash, which does the splash screen. Another method here called reset. So this resets the game, you know. And then very importantly, this is typical of your processing sketches as well. Instead of having my drawing code inside the draw method, instead I've written a method called drawBug. And this takes the x and y coordinate where you want the bug drawn on the screen as parameters, and then it has all the drawing code in here. You see that? So this is a good use for your methods. Whenever you want to draw something on the screen, it makes sense to pass in a couple of parameters and have it draw the thing wherever it needs to draw on the screen. This is where you use this in the real world. And if you scroll down here, you'll see that my actual draw method is really small now. Even though my entire game is doing lots of different things, my draw method is only like 10 lines of code. You know, because everything else is off in methods doing stuff when I just call them. So I call the splash method, then I call the game method. The game method is going to call the drawBug method, you know. So I've divided my big processing sketch into lots of small bits